Everyone. Today we'll see the sinusoidal response of RL series circuit. So if you apply the sinusoidal AC voltage source of V cos omega t plus theta through a switch S to the RL series circuit, the response I we need to find it out. So when the switch S is closed at t is equal to 0, the V cos omega t plus theta is applied to this RL circuit. So in V cos omega t plus theta, V is the amplitude of wave, theta is the phase angle, because this is RL circuit and the sinusoidal voltage source we have applied. When you apply KVL to this loop, voltage source is equal to R into I plus L into dI by dt. So by applying KVL, we'll get the equation like what is voltage source? V cos omega t plus theta is equal to R into I plus L into dI by dt. By rewriting this equation as d by dividing on both sides with L, di by dt plus R by L into I is equal to V by L into cos omega t plus theta. V by L into cos omega t plus theta. The corresponding characteristic equation is, by considering d is equal to d by dt, d plus R by L in R by L of I is equal to V by L cos omega t plus theta. The corresponding equation is consist of two parts, because right side is not equal to 0. So hence it has two parts. One is complementary function and the one is particular integral. So total I is equal to I complementary plus I particular. So the complementary function solution will get directly from I complementary is equal, even in the previous case also we have seen in the previous videos, you can go through it. IC is equal C into e power minus pt, where p is nothing but the coefficient of I. C into e power minus R by L into T is the complementary solution. Now we need to find out this particular solution also to find out the overall solution. The particular solution can be obtained by using the undetermined coefficients by considering the particular solution equation as IP is equal A cos omega t plus theta plus B sin omega t plus theta. You may get both cosine and sine coefficients and both cosine and sine terms. That's why I'm considering here A cos omega t plus theta plus B sin omega t plus theta as particular function. In this equation, if I differentiate this equation di, because to further use, I'll use this differentiation of this particular integral in further equation. That's why I'm differentiating here. Dip by dt is equal, which is nothing but Ip dash is equal, by differentiating this, coefficient of t will come outside of that cosine and cos will become sine, minus omega into sine omega t plus theta, and differentiation of sine is nothing but cos. Again coefficient of t will come outside, b omega into cos omega t plus theta. So if you see this is fourth equation and fifth equation. Substitute this fourth and fifth equation in the equation 1. Here equation 1, if you see in the equation 1, I have di by dt and R by L into I. As I'm finding out the particular integral of current, so I'll use dip by dt plus R by L into Ip is equal V by L into cos omega t plus theta. Dip by dt, dip by dt and R by L into I. Both dip by dt and Ip I'll substitute in the equation, so that I'll get dip by dt is nothing but this one, minus a omega sine omega t plus theta plus b omega into cos omega t plus theta, plus Ip is nothing but R by L into Ip. Ip is nothing but a cos omega t plus theta plus b into sine omega t plus theta. So which is equal V by L into cos omega t plus theta. So by taking this sine and cosine coefficients common, sine omega t plus theta, here it is sine omega t plus theta, R by L into b, and here you have minus a omega plus b R by L of sine omega t plus theta, here b omega R by L into a, b omega plus a by R, a by L of cos omega t plus theta is equal to V by L cos omega t plus theta. By comparing both cosine and sine terms on both sides, you have right side there is no sine term, so sine coefficient on the left side is equal to 0. What is the sine coefficient here? Minus a omega plus b R by L is equal to 0. Out of this you'll get a is equal to b R by omega L. By taking this br by L r by a omega on the right side, if you'll get a is equal to br by L. And by comparing cosine terms, b omega plus ar by L is equal to v by L. I'll substitute this a term in this equation so that we'll have only b unknown coefficient that we can find it out. By substituting this a, b omega plus a into r by L, a is equal to br by omega L, br square by omega L square is equal to v by L. By taking this b common and by cross multiplying, you will get it as b into omega square L square plus r square by omega L square is equal to v by L. Both L and L will get cancelled, so that b is equal to v into omega L will go on the other side, omega L by r square plus omega square L square. Substitute this b value again in the a coefficient, so that you will get a is equal to v into r by r square plus omega square into L square. Now I got both a and b coefficients. So one is a coefficient and the other is b coefficients in terms of circuit elements and supply voltage. I got both a and b coefficient. That I'll substitute in the IP equation. What is the IP equation? IP equation is nothing but a cos omega t plus theta. A value I have substituted here, a term, plus b sin omega t plus theta. B also I have substituted here. So here again, for further simplification, I am assuming this coefficient of cos omega t plus theta as m cos pi and coefficient of sin omega t plus theta as m sin pi. So this is m sin pi. This I am assuming it as m cos pi. By substituting that m cos pi and m sin pi in this equation, sixth equation, I'll get IP is equal to m cos pi into cos omega t plus theta plus m sin pi into sin omega t plus theta. By taking this, now I am assuming this as ninth equation. If you see this, m cos pi is seventh equation, m sin pi is eighth equation. To find out this pi or to find out this m value, what I am doing here is I am dividing both 8 by 7, 8 and 7. If I do that, m sin pi is divided by m cos pi, which is equal to tan pi is equal to, if I divide both of these, v by r square plus omega L square, v by r square plus omega L square will be common, omega L by r on the right side, omega L by r. So pi is equal to tan inverse of omega L by r. Now I got pi by dividing 8 by 9, 7th equation with the 8th. And to get that m value, I'll square both the equations, 7th equation or 8th equation square plus 7th equation square. That is nothing but m sin pi square plus m cos pi square, m sin pi whole square plus m cos pi whole square. On the right side also, if you see, I'll square of both these terms, v square omega L square by r square plus omega L square whole square plus v square r square by r square omega L square whole square. So if you see here, r square plus omega L square, one term, if you take the v square common, in the denominator you have square of those terms. So one term will get cancelled, v square by r square plus omega L square, which is equal to m square. Sin square plus cos square pi is equal to 1. So only on the left side you have m square. Square and the square terms. So here you will get the term like m square is equal to v square by r square plus omega L square. If you want only m means, I'll take this square on the other side, it will become square root. Square root of v square is nothing but v by under root of r square plus omega L square. Now I got both m and pi values. I'll substitute this m and pi values in the IP equation. So what is IP equation? IP is equal to m of cos omega t plus theta into cos pi. I am rewriting this equation. Cos omega t plus theta into m cos pi, right? So first I am writing cos omega t plus theta. Cos omega t plus theta into cos pi plus sin omega t plus theta into sin pi, m common. So out of that, if you see, if I am assuming this omega t plus theta is equal to a, b is equal to pi, cos a cos b plus sin a sin b, which is nothing but cos a minus b. That's why here I'll get cos of omega t plus theta minus pi into m. I know the m value that I am substituting here, v by under root of r square plus omega L square from here. Cos omega t plus theta minus pi is equal to tan inverse of omega L by r, tan inverse of omega L by r. Now I got particular integral also only in terms of circuit elements. So complete solution is nothing but I is equal to I complementary plus I particular. I complementary in the starting itself we have find with the arbitrary constant I is equal to C into e power minus r by L into t plus IP I have substituted here. The same IP value I have substituted. Out of this equation only one constant is there, that is C. To find out this C, use the initial conditions. What is the initial condition? Inductor does not allow the sudden changes in current. At t is equal 0 only we are closing the switch. At t is equal 0 minus also, the switch is in open position. Switch is in open position means as it is single loop, switch is in open position means current is equal to 0. When current is 0 at t is equal to 0 minus at t is equal to 0 also current is 0. That I am substituting. I of 0 is equal to 0, which is equal to C into e power minus r by L into t, that is equal to here 0 I will substitute. So I will get I of 0 is equal to 0, which is equal to C into e power 0 plus v by under root of r square plus L square cos 0 plus theta minus tan inverse of omega L by r. C into e power 0 is equal to C. E power 0 is equal to 1. So this entire term will go on the other side. That will become C is equal to minus v by under root of r square plus omega L square to cos, as this first term is 0, theta minus tan inverse of omega L by r. Now I got C value. That C value I will substitute in this equation. So I will get the complete solution. I is equal to e power minus r by L into t into C. C is equal to minus v by under root of r square plus omega L square into cos theta minus tan inverse of omega L by r plus v by under root of r square plus omega L square into cos omega t plus theta minus tan inverse of omega L by r. So this is all about the sinusoidal or AC response of RL circuit. Thank you all.